This is session 3 of lesson 29. We're looking at the last session here. So, number 1, evaluate. Raphael says the question below is a statistical question because there is more than one possible answer. Explain why Raphael is incorrect and tell how you can modify that question so that it is a statistical question. Does my math teacher prefer reading history books or graphic novels? Okay. So, if you're thinking about with what we've been thinking about on the same lines, so does my math teacher prefer reading history books or graphic novels? This question is not going to include collecting data that could vary. Most likely the person's either going to like the history books or the graphic novels, so it's going to be one answer. It's not going to vary. You can change this question to, do teachers in the school prefer reading history books or graphic novels? And that would make it a statistical, because it's going to vary from person to person. And you could have a dot plot showing, not a dot plot, excuse me, you can't do both of those. You could have like a frequency table, and you could put history books and graphic novels, and you could put tick marks in between them to see which one is like the most. So I would maybe change it so that you write it like that. You can write it however you'd like to in your own words, but I do want to write it down so you can see it. So the question that he provides does not require collecting data. All right, so it's just going to be either history books or graphic novels. So he could ask, remember, he could ask all teachers at school which they prefer. Okay, so he could ask all the teachers, and then I would just put it like that. So he could ask all teachers at school which they prefer, and everybody's gonna have their own opinion. Remember, it's an opinion question, so those are usually your statistical questions. Number 2, compare which question would likely result in more variability if you asked each student in your school. So explain about how many hours per week do you play sports and what grade are you in. Okay, so think about this. About how many hours per week do you play in sports, or what grade are you in? So if you think about our school, the middle school, there's 3 grades in the school. So if you ask each student in our school, you're going to get 1 of 3 answers. You're either going to get 6th grade, 7th grade, or 8th grade. Now, if you think about how many hours per week do you play sports now, that is going to vary from person to person. A lot of people in our school don't play sports. That would be 0. A lot of people play football, which takes more amount of hours. Band students, I don't know if you want to consider that a sport. That could be considered practice time after school. And like maybe band concerts, I don't know what you would count there. The dance team dances a lot. They have practice almost every day, it seems like. Basketball is starting to practice now, so that would probably vary. So I would say the question about the sport is going to be the one that has more variability. Again, what grade are you in? You could say this question will only be 1 of 3 answers. Remember, we have 6th, 7th, and 8th at our school. So you don't only get 1 of those 3 answers. So it's not going to be a lot. Okay? Number 3, we're predicting. So the dot plot shows the cost per ounce of different brands of peanut butter sold at a store. The store plans to add a new brand of peanut butter. The new brand has a 16-ounce jar that sells for $3.84. Based on its cost per ounce, I'm just going to go ahead and underline that. Do you think the new brand is a good deal compared to the other brands, and use this distribution shown in the dot plot to support your answer? Okay, so to find the cost per ounce, here's your ounce, here's your cost. Remember cost, that's 3 cost per ounce. I need to divide the 2. So when I divide the 2, I'm going to get 24 cents per ounce. Okay, so looking at the peanut butter that they've got already, the cost over here, that's going to be like over here. So I would say no. In my opinion, I want to save my money, so no. That's not a good deal compared to what's already there. Now, it may be the best peanut butter ever, and it may taste great, so I get that, but for what's already at the store, I wouldn't say it's a good deal compared to the other brands. You could say the other brands are spread from, looks like from 11 cents to 16 cents. Notice how I didn't say 10 and I didn't say 17. I don't have any dots there. So from 11 cents to 16 cents per ounce. So if you look at that, the new brand is so much more expensive per ounce compared to the ones that are already there. So no, it's not going to be a better deal. All right, number 4. So number 4 is looking at the data from a drone here and the flight times. And we want to use a model to represent the distribution of the flight times. So what I'm going to do is, first of all, when I'm making a dot plot for this, I'm going to look at the numbers they give me to see how many ticks I have. Notice how I have a decimal here, okay? So I need to look at my decimals and see, are they all the same or are they varying? So is it going to be like a 0.25, a 0.5, a 0.75 to see how many tick marks I need to put. Here it's only 0.5, so all I'm going to do is break it 1 with a tick between it, 1.5 to 2.5. I don't need to go into quarters or fourths or tenths or anything like that. So don't make it any harder than it has to be or more time consuming than it has to be. Then I'm going to pick my smallest number and go from there. Let's see. So looks like I've got a 3 here, a 3 here. So 3 looks like it's going to be the smallest number here. Okay. From there, I'm going to look at my biggest number. So I'm not just drawing numbers all the way to, infinity. Looks like 10 is going to be my biggest number. So I'm going to go all the way to 10. Now remember, I have halves, so I need to do halves also. So 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, and 10. Okay. I don't have any 10.5, so I don't have to do another 10, but and a half, but you can if you want to. All right, so then I need to count my numbers here. I'm going to go ahead and mark them out as I go through so I can see them. So I've got 2 3s. 2 3s. Let's see, we've got a 3.5. We don't have any 4s, but it's still represented there, so just don't put anything over it. I've got 1 4.5, 2 4.5s. Okay, I have, let's see, 5s. We have 1, 2, 3, 4, 5 5s. That's a lot of 5s. Okay, 5.5, 1. We don't have any 6s, but I've got 2 6.5s. Okay, let's look at my 7 here. So we've got 1, 2, 3 7s. And I can see here that I've missed a 6.5, so I'm going to go add another 6.5. So I have 3 6.5s. And then let's see, there's, looks like 2 9s. And 2 10s. Okay, just to make sure I'm going to count all of my dots and I'm going to count all my numbers. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. You could have counted it 7 times 3. But I wanted to count them just to make sure. So I need 21, so that's 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, and I did skip 1, but notice all I had to do was go back and add another dot. Okay. So, part B, about how long does a drone typically fly, and explain your reasoning. So what you need to do is look at where your biggest group of numbers is. If I was looking at this and I said about how long does a drone typically fly, I probably wouldn't say 10 because I only have 2 there. He's got 21 toy drones. I've only got 2 out here and 2 right here. So I'd say there's probably, I don't know, maybe he didn't drive as far or as high or something happened that day that they could drive a little bit further or fly a little bit further. But my majority is going to be around this area. Okay, so a typical drone looks like it flies for about 5 minutes. Okay, so it looks like that's going to be your peak too, your mode. So about a third of the data, so about a third of it, you could say a third of the data is going to range from your 4.5 to 5.5. So the majority looks like it's about right here. Okay. And then your math journal is for you to do on your own again, just like the reflection questions. So Augustine collects the data set shown in the dot plot to answer the question, how many days each week do students in my class eat a cafeteria lunch? And why is Augustine's question statistical? Describe the distribution of the data collected to answer the statistical question. Okay, so you're going to go through it. You're going to think, why is it statistical? Okay, look at it varying. And then describe the distribution. So you might want to say there's a peak around some area, the spreads from here, the range is that. Just like we've been doing, okay?